Welcome to SmartTeller Academy. Have you ever asked an AI a question and received an answer that sounded confident, but was completely wrong? This problem is known as AI hallucination. Large language models like ChatGPT are incredibly powerful, but they only know what they were trained on. They don't automatically know your company's documents, your school's handbook, or your latest business reports. So how do we make AI answer questions using our own data? The answer is Retrieval-Augmented Generation, commonly known as RAG. In this lesson, you'll learn what RAG is, how it works, and why it has become one of the most important technologies in modern AI. Let's begin. 1. What is RAG? RAG stands for Retrieval-Augmented Generation. It is an AI technique that allows a language model to retrieve relevant information from an external knowledge source before generating an answer. Instead of relying only on what it learned during training, the AI first searches your documents, finds the most relevant information, and then uses that information to answer your question. Think of it this way. Imagine you ask a university librarian, "What are the admission requirements for computer science?" Instead of answering from memory, the librarian first searches the university handbook, finds the correct page, reads it, and then gives you the accurate answer. That is exactly how RAG works. The AI becomes much smarter because it answers based on trusted information instead of guessing. Without RAG, question goes directly to the AI. The AI answers from memory. With RAG, question goes to the knowledge base. Relevant documents are retrieved. Those documents are sent to the AI. The AI generates an accurate answer. This is why companies use RAG to build customer support bots, internal assistants, document search systems, and AI-powered knowledge bases. 2. RAG architecture. Now let's understand the architecture. Although RAG sounds complicated, it follows a simple pipeline. There are 5 major steps. Step 1. User question. Everything begins with a user's question. For example, what is the company's leave policy? Step 2. Convert the question into an embedding. The question is converted into a numerical representation called an embedding. We'll explain embedding shortly. Step 3. Search the vector database. The embedding is compared against thousands or millions of document embeddings stored inside a vector database. The database finds the documents that are most similar to the user's question. Step 4. Retrieve relevant documents. The most relevant documents are retrieved. For example, the employee handbook or HR policy document. Step 5. Generate the final answer. The retrieved documents, together with the user's question, are sent to a large language model. The AI now generates an answer based on the retrieved information. Because it has access to the correct documents, the answer becomes more reliable and accurate. This entire process usually happens in just a few seconds. 3. Embeddings. Embeddings are one of the most important concepts in RAG. An embedding is a numerical representation of text. Computers cannot understand words directly. They understand numbers. So AI converts every sentence into a list of numbers called a vector. For example, I love programming might become 0.24, 0.81, 0.67, and hundreds of other numbers. You don't need to understand the mathematics. The important idea is this: sentences with similar meanings produce embeddings that are close together. For example, I enjoy coding and I love programming. We'll have very similar embeddings, but I like eating pizza will have a very different embedding. This allows AI to search based on meaning instead of exact words. That is called semantic search. Instead of searching for matching keywords, the AI searches for similar meanings. That is why RAG systems are much more intelligent than traditional search engines. How RAG works in real life. Imagine a hospital has 50,000 patient documents. A doctor asks, "What medication is this patient allergic to?" Instead of reading every document manually, the RAG system searches the medical records, retrieves only the relevant documents, and allows the AI to answer almost instantly. The same idea applies to banks, universities, law firms, government agencies, and businesses. Any organization with lots of documents can benefit from RAG. Why RAG is better than fine-tuning? Many beginners confuse RAG with fine-tuning. Fine-tuning changes the AI model itself. RAG does not. Instead, RAG simply provides relevant information during the conversation. That means updating your knowledge base is as easy as adding new documents. You don't need to retrain the AI every time your information changes. This makes RAG faster, cheaper, and easier to maintain. Benefits of RAG. Let's summarize the advantages. First, it reduces hallucinations because the AI answers using trusted information. Second, it allows AI to work with private documents. Third, your knowledge can be updated without retraining the model. Fourth, it improves answer accuracy. Finally, it scales easily to millions of documents. These advantages explain why many modern AI assistants rely on RAG. What you will learn next. In this course, we're just getting started. In the next lessons, you'll learn how to build complete RAG systems using professional tools. You'll explore vector databases such as Pinecone, ChromaDB, and Weaviate. You'll also learn powerful AI frameworks including LangChain and LlamaIndex. Finally, you'll build real-world projects like a chat with PDF application, a knowledge base assistant, and a complete enterprise RAG system. Let's quickly recap today's lesson. RAG stands for Retrieval-Augmented Generation. Instead of answering only from memory, the AI retrieves relevant information before generating a response. The RAG pipeline consists of a user query, embedding generation, vector search, document retrieval, and AI response generation. Embeddings convert text into numerical vectors, allowing AI to search by meaning rather than exact words. This makes AI systems more accurate, more reliable, and far more useful for real-world business applications. Thank you for watching. Like and follow for more.